MQTT is designed as a lightweight messaging protocol. Its small size, low power usage, minimized data packets, and ease of implementation make the protocol ideal of the machine-to-machine or Internet of Things world. MQTT concepts. 1. Publish, subscribe. The first concept is the publish and subscribe system. In a publish and subscribe system, a device can publish a message on a topic, or it can be subscribed to a particular topic to receive messages. Two, messages. Messages are the information that you want to exchange between your devices, whether it's a command or data. Each message has a topic, some attributes, and a payload which contains the data to transmit. The sending client, publisher, decides whether it wants to send binary data, text data, or even full-fledged XML or JSON. 3. Topics. Other important concepts are the topics. Topics are the way you register interest of incoming messages or how you specify where you want to publish the message. Topics are represented with strings separated by a /. Each / indicates a topic level. Publishing to the topic, home/bedroom/temperature. Four, broker. Broker refers to the server that handles the data transmission between the clients. The broker is primarily responsible for receiving all messages, filtering the messages, deciding who is interested in them, and then publishing the message to all subscribed clients. For example, in the diagram above, you can see that client number 1 publishes data to topic 1 and topic 2, and at the same time, it is a subscriber to a topic 3. Client 2 is subscribed to all 3 topics, and so on. Let's see how data is transferred in this case. Client 1 is publishing data to topic 1. The broker sends the data to all subscribers, Client 2, Client 3, and Client 4. Client 1 is publishing data to topic 2. The broker sends the data to all the subscribers of that topic, Client 2 and Client 3. Client 3 is publishing data to topic 3. The broker sends the data to all the subscribers of that topic, Client 1 and Client 2. Client 4 is also publishing data to topic 3. The broker sends the data to all the subscribers of that topic, Client 1 and Client 2. Client 4 is publishing data to topic 2. The broker sends the data to all the subscribers of that topic, Client 2 and Client 3. To use MQTT, you need to decide what MQTT broker you will use. You can either select cloud-based brokers or self-hosted brokers that run on an internal network or internet. Cloud-based broker. Developers' only responsibility is for the installation and management of software, while the server hardware is provided and maintained by the vendor. Some of the vendors also provide managed MQTT broker where even the server software and the MQTT application is installed and managed by the vendor. Self-hosted broker. A developer can install these brokers on his own server. In this case, the developer himself is responsible for all installation and maintenance of server software and hardware. MQTT features of an IoT Rievtech PLC. To ensure the deployment of IoT networks based on IoT Rievtech PLC or the implementation of controllers in existing IoT networks, a user can apply 5 functions in XLogicSoft functional blocks. Connect to the MQTT server is designed to establish communication between the PLC and the broker. Publish. As the name implies, this block is intended to publish information configured in the block settings to the broker in the specified topic. Block Subscribe is used to receive data from the broker. In the settings of this block, you specify the topic whose data you would like to receive from the broker, as well as select the registers in which you will store this information on the PLC for further processing. The following two blocks are used to work with the received data. The first is string to integer, which allows you to translate string data from an MQTT message into a numeric value that is generated at the output of the block. The last block is intended for processing data received from the broker, string comparator. The purpose of this block is a character-by-character comparison of the string specified in the block settings with the string stored in the controller. If the lines match, the block output is set to state 1. Before proceeding to a more detailed look of the capabilities of MQTT blocks, we need to highlight some points that are important in order to establish a connection with the broker and for sending, receiving MQTT messages, as well as storing them in the PLC memory. MQTT is an application layer protocol, i.e., at the level where the data is exchanged between specific applications. But in order for such interaction to occur, it is necessary to establish communication at a lower level, namely the connection at the transport level. This kind of connection is established using the TCP/IP protocols, over which MQTT protocol runs. To establish a connection to the broker via TCP/IP, you need its IP address and port. The data is specified in the settings of the Connect to MQTT block. This block can be used only once in a program. To store data received from the broker and process it in the Rievtech IoT controller, 3 types of variables are used, which are represented by the following blocks: variable byte, variable word, and variable double word. Variable byte sets the memory address for storing 1 byte of data, which can be represented by 1 ASCII character. Variable word sets the memory address for storing 2 bytes, 16 bits, of data or 2 characters of ASCII encoding. Accordingly, variable double word is designed to store 4 bytes, 32 bits, of data or 4 characters of ASCII encoding. The memory area used by these 3 blocks is the same that is used for AF blocks. In the diagram above, you will see how memory is addressed for blocks VB, VW, and VD. Also, this addresses intersects of each between AF blocks. This is how VW blocks correspond to memory registers with AF blocks. The bit addresses are the same for both blocks. The addressing of VW blocks is performed according to the following scheme. Please note that the VW block number is the same as the VB block number and overlaps the memory area from the previous VW block. And also with VW blocks, the bits are counted in the opposite direction compared to the VW and AF blocks. The same principle applies to VD blocks with overlapping the previous block and reverse bit numbering. A practical example of organizing data transmission using MQTT and IoT Rievtech PLC. First, we need to select and configure a broker. For our example, we will use the cloud service, Cloud MQTT. We'll be going through a simple registration procedure. Creating an instance that will act as a broker. To demonstrate, we will use the free package provided by the service. After creating the instance, we can see the information with its settings. We are interested in the server name and port for establishing TCP/IP connections. The username and password are needed for authentication when publishing or subscribing to our broker. As an example, we will consider the task of automating a greenhouse. We will transmit temperature and humidity data to the broker, as well as the status of all outputs. We will receive commands from the broker to manually turn on or off the heating, as well as the ability to set the temperature at which the heater will turn on. We have already prepared a control program. Let's now configure the broker's connection with the PLC. For this example, we will need 3 publish blocks and 2 subscribe blocks. To connect the PLC to the broker, we'll need the MQTT connect block. Let's prepare TCP/IP connections with the broker. As we see, in order to specify the broker's address for establishing a TCP connection, we need to know its IP address. In our example, the Cloud MQTT service provided by the broker's DNS address. The IP address can easily be found using the standard Windows ping command on the command prompt. Now, let's enter the obtained broker IP address in the settings of our TCP connections. We also have to specify the port to connect to the broker. Please note that some brokers allow to connect both through a secure connection and through the unsecured one. Different ports are used for this. By default, TCP connections do not use an encrypted communication. To encrypt the whole MQTT communication, many MQTT brokers, such as cloudmqtt.com, allow the use of TLS instead of plain TCP. If you apply the username and password fields of the MQTT Connect packet for the authentication and authorization mechanisms, you should strongly consider using TLS. In our case, we'll connect to the broker through an SSL/TSL connection, and we always recommend doing this in your projects. Therefore, we specify the appropriate port for secure connection. Ping interval time. The time interval that regulates the transmission of ping requests and ping responses to control the disconnection of one of the parties. Next, we need to activate a secure SSL/TLS connection. After that, a field will become available in which we can specify the root CA certificate. Where and how to get the certificate is normally indicated in the documentation for the broker. For cloudmqtt.com, the documentation FAQ section indicates that the service is signed with the Komodo certificate. To get it, follow the link provided at the bottom of the page. Download it. Returning to the settings of the MQTT Connect block, indicate the path to the Komodo CA certificate, just downloaded in the corresponding field. Client ID is a unique identifier for each client connecting to the broker. Username, password. Username and password refers to the identification and authorization of the MQTT client to the broker. This completes the setup of the MQTT connection block. Now we can add the publish and subscribe blocks so we can send or receive data. The first publish block will send the current temperature data to the broker in the topic greenhouse-1/temperature/measured. Let's look at the settings available in the COM tab. The quality of service QoS level is an agreement between the sender of a message and the receiver of a message that defines the guarantee of delivery for a specific message. QoS 0. The recipient does not confirm receiving the messages. The sender accordingly transmits the message just once without attempting to retransmit it in the future. This is the send and forget method. QoS1. It is guaranteed that the receiver will receive a message at least once. In this case, the subscriber can receive the same message several times. The sender will make repeated attempts of sending it until it receives a confirmation of the successful delivery of the message. Retained flag. A retained message is a normal MQTT message with a retained flag set to true. The broker stores the last retained message as well as the corresponding QoS for that topic. Each client that subscribes to a topic pattern that matches the topic of the retained message receives the retained message immediately after they subscribe. Retained messages help newly subscribed clients get a status update immediately after they subscribe to a topic. The retained message eliminates the wait for the publishing clients to send the next update. You can send messages to the broker with a certain period. For this, you need to activate the publish interval time and set the parameter value to seconds. If the function is not activated, then sending will occur only once when the block is activated. Thus, you can control the sending of messages by some event. In the next field, you indicate a topic so that this block will post messages. Fill in and configure the settings on this tab. Next, switch to the Parameter tab and specify what kind of data our block will publish. Press the Add button and select the block of data which we need to send to the broker. In this case, the measured temperature is in the analog flag AF50. In addition to the value of the block itself, we can add any characters before the value in the comment field and after the value description. Let's make sure that the temperature values are published with a sign of degrees Celsius. Checking the settings and saving by clicking OK button. Publish Subscribe. Blocks have one set input, which activates the connection with the broker and two outputs. One output is discrete, which is activated when the connection is successfully established. The second, analog output, is that which the data transfer status code appears. See the user manual for complete list of codes and their decryption. In our example, all publish and subscribe blocks will be active all the time. So we will connect their inputs to a status 1 high block. The intervals of data, publishing, receiving, will be regulated by the settings of interval time. Now let's add another publish block that will send humidity sensor data to the broker in the greenhouse-1/humidity topic. Another publish block will send the status of all outputs to the greenhouse-1-outputs/status topic. Now we will configure it. Remote on-off command for the heater will be sent by another MQTT client's smartphone web browser to the broker in the greenhouse-1/heater/control topic. So we need to subscribe using the subscribe block, our PLC on this topic, to receive these commands. The parameters of the Subscribe block on the COM tab are similar to the Publish blocks ones. Now let's go to the Parameter tab. Here we can identify the initial VB variable in which the first character of the received message will be stored, and indicate the exact number of characters in the message if we know that number. A message consisting of 3 characters will be enough for us to turn on/off the heater, on or off respectively. In the variables VBO-VB2, the line with the command will be stored. To generate a control signal in accordance with the required command, we need string comparator block. We add these blocks to the program, connect them, open their settings, and set for both the same initial variable, VBO, as the starting variable. In the string field, enter on and off for the corresponding blocks, which should generate a command to turn the heater on or off. Clients will send temperature settings to automatically turn on the heater in the greenhouse-1/temperature/threshold topic. To obtain this data, we need one more subscribe block. Let's configure this block as well. Here we need the first 2 characters of the message containing numbers with the temperature value of the set point. We save these characters in variables VB3 and VB4. The received characters are still a string and not a numerical value that can be transferred to the block to set the temperature for the heater. To perform such a conversion, you must use the string to integer block. In the settings of this block, we indicate the initial variable in which the first character of the string is stored and the number of characters that we convert to a numerical value. Set VB3 and the count is 2. Next step, connecting the input of the block and the analog output, on which we get the converted numerical value, to the analog flag AF20, which is used to set the temperature for turning on the heater. Well, the final step is to add VB blocks, where the data received from the broker will be stored. After uploading the program into the PLC, let's check the data exchange between the PLC and the broker. This can be done using the Cloud MQTT service itself. Go to the WebSocket UI tab and see that the PLC has already started transmitting data to the broker. Now let's check on the received data by the controller from the broker. To do this, send a command message on to turn on the heater in the topic greenhouse-1/heater/control. We see the heater turned on. Next, we send the message 24 to the topic greenhouse-1/temperature/threshold in order to set a new value to turn on the heater in automatic mode. As you can see, the controller received this message, processed and placed it in the AF20 flag. During this time, the controller has already sent several messages with values of temperature, humidity, and output status. Thus, we see that all of our published blocks work successfully. We can also demonstrate how MQTT works with IoT PLC using the MQTT Dashboard smartphone app. Connecting to a broker. Turn off the heater by publishing the message off in the topic greenhouse-1/heater/control. And then set a new temperature setting. topics with the temperature and humidity values. As you can see, everything is transmitted and sent through the Android application.